All right, so I'm recording these sections now. All right, so the general outlines of these sections, I will go through briefly as explaining who we are. And also I will look into the overview of SeismoBuild 2020 software. And then I will go into the last section, which is our tutorial section for today, which is look into the seismic evaluations of a two-story reinforced concrete buildings. I will explain this thing in details later on. All right. So as a start is who we are, who is Wallingford Consultancy. Basically, we are the solution providers to the architecture, engineering, and construction industries in the Southeast Asia regions. So basically, we provide three main services. One is into the software solutions. We also provide trainings either as a physical training or like in this case here, the webinar trainings. And also time to time, based on the client requirements, we also offer consultancy services. So we are very specialized consultancy, look into nonlinear analysis and modeling of structures. And also together we also got some other interests, look into BIM, BIM digital construction as well. All right, this is a general overview about who we are. And we are currently collaborate with some of the leading partners and institutions. One of them is, of course, is SeismoSoft. So the second part of my session, I will look into this, the general overview about the SeismoBuild software itself. All right. So SeismoBuild actually is developed by a company called SeismoSoft. So SeismoSoft, if you search Google, you can know that it is recognized as one of the leading providers of earthquake engineering software solutions. So basically, they develop a lot of specialist software applications for analysis of structures subject to seismic actions. So some of their software product include, of course, SeismoBuild, which is we're going to discuss for today, and also SeismoStructures, SeismoSelect, SeismoSignal, SeismoMatch, SeismoActive, and SeismoSpec. All right, so SeismoSoft is one of the very leading software provider of providing a lot of earthquake engineering software solutions. All right, so for today is our particular attentions, which is looking into the SeismoBuild programs. So so SeismoBuild actually is a very innovative Final 11 programs, especially developed targeted to the design office. That means to the normal typical design office in the design environments. It's a very, very powerful programs, and it's very, very affordable if you compare to some of the mainstream program that can do exactly the same thing. So we are exclusively dedicated to seismic assessment, evaluations, and retrofitting of reinforced concrete buildings. So we are proudly considered as one of the only software in the world that can do, especially look into the retrofitting of the reinforced concrete buildings. Later on in these tutorials, I will explain that in more details. The program is capable of carrying, of fully carrying the code-defined assessment methodology. So basically from the structural modeling through to the required analysis, the corresponding member checks, and the creation of the technical reports, and also the CAD drawings. So SeismoBuild actually they are currently supported 5 international design codes in seismic assessment. All right, so all these 5 international design code already implemented in our SeismoBuild software, our program, which is Eurocode 8 Part 3, which is Part 3 specialized look into the assessment and retrofitting of buildings, and of course ASCE 41, which is the discussion for today. We're going to use this code to assess the building, ASCE 4117, and also the Italian National Seismic Code, NTC 2008 and 2018, and also the Greek Seismic Intervention Code and the Turkish Seismic Evaluation Building Codes. All right. So the general overview, SeismoBuild is built based on the nonlinear analysis software. So when we talk about nonlinearity, it basically includes 2 components. You look into the geometrical nonlinearity and also the material elasticity. This program actually is built based on our original program, which is SeismoStruct. If you look into the history of SeismoSoft have been for nearly 20 years now. It's a very established program. It's based on a very advanced solution algorithms. So SeismoBuild actually are based on the same algorithm and same solver of SeismoStruct. So because this software, SeismoStruct, have been extensively used and validated by thousands of users all over the world for more than 10 years, 15 years now, 20 years now. And then the accuracy is without questions, have been well documented, well demonstrated. Beside from the validations, or also got many success in many of the blind test prediction exercise. So I would like to share with you some of the recent blind prediction competition that we have won last year. So last year, one of the team of the from University IUSS Pavia, Italy, had joining in one of the conference organized by Quick Call in 2019. In one of the blind prediction competitions, the winning team is using SeismoStruct in winning the competitions. All right, so you can find out more details on this in our website, actually in our SeismoSoft website. But besides from on 2019, over the last few years in the past, we also won a lot of blind prediction competition as well. This is one of the most recent one. All right, so the general overview of our SeismoBuild 2020 features start with is we got nonlinear analysis capability, which is pushover analysis, and also we are performance-based seismic based on performance-based seismic methodology. All right. Secondly, is we can implement what we call the strengthening interventions. We can apply after you have done seismic assessment. If there's come across some certain part of the building is critical, you need to do retrofitting and strengthening. So SeismoBuild, we can implement strengthening intervention into your existing structures. Of course, try to define, of course, code define capacity check is something what we can do as well. Our interface are very easy and very easy to follow, and later I will show you. And then in terms of generation of technical reports and also CAD details and drawing after you completing your assessment and retrofitting. All right, so this is very general feature of what SeismoBuild 2020. In terms of our license, we currently offer two types of license. So in generally, our full license is a perpetual license, it's a single license, perpetual license. We also offer, beside the full license, we also sometimes time to time based on the request of our client, maybe based on the project duration, type of projects, they're requesting for rental license. We are offering two, either 3 months or 6 month license for much more shorter project durations. All the pricing of the license does not include any technical support, are purely for the software only. So usually for the first year, we try to be more advisable. Our client is much more mandatory for first year technical support. So usually the charge usually between 15 to 25% of the software price. For the subsequent year, it's much more optional. Usually we try to be more highly advisable for technical support for the first year, because when you try to use SeismoBuild software, we are dealing with nonlinear analysis, nonlinear capability. So it's something quite different compared to other linear programming. So usually the first year, the learning curve is not as steep, but you will be usually expect for the first 3 to 6 months, where you got a lot of questions, you might need our support. And also last, there will be the upgrade. Usually our upgrade is done every minor upgrade, usually every year, but every major upgrade is every 2 years. And it's optional, depends on whether the client want to go ahead with the upgrade or not. If based on our existing client, the upgrade usually is about 50% discount if you want to have the latest upgrade on the latest versions. Right. So this is a generally overview about SeismoBuild 2020. So now I'm going to go on to our next section, which is our tutorial. Okay. So for this tutorial is we're going to explore some of the very basic features of SeismoBuild. Will be presented with very comprehensive examples, very simple 2-story building, but in a very comprehensive review assessment on the building on the use of this software. All right. So the general objectives. So upon completion of this tutorial, you should be expected to know how to model a two-story building using this SeismoBuild program, using the SeismoBuild Building Modeller Facilities, and of course conduct a seismic evaluation on the building according to the ASCE 4117, and then perform a full procedure of nonlinear pushover analysis on the structures and assign the capacity of the building, and also most importantly to apply the strengthening or retrofitting intervention to the buildings. All right, so this is a general overview. Upon completion of this exercise, you should be able to achieve. So in this tutorial, I go to divide it into two parts, stage 1 and stage 2 actually. Roughly stage 1 it take me about 45 minutes because we're going to completely model a two-story building from scratch. And then after we model it, then we're going to conduct a full seismic evaluations according to ASCE 41. And then after we conduct our assessment evaluations, then we identify what is the critical elements and the analysis. Then after that is we apply from the result what we have from stage 1 to stage 2. All right. So once we have identified maybe some of the critical elements and analysis, then we try to apply some strengthening and retrofitting intervention to the critical elements. Then after that, we will reanalyze again, reevaluate the seismic capacity of the retrofitted buildings. All right. So it's basically divided into two stages. Stage 1 to about 45 minutes. Stage 2 roughly about 30 minutes. So the general overview, this is the first stage, upper completion. This is the general overview of these these buildings. It's a very simple double-story, two-story buildings. All right. So what I'm giving you is a front view and a back view of the building itself, and also the structure plan of this building. I believe that as what I mentioned when I started this presentation, I already sent through my email a link of all the presentation material, which is the PowerPoint slide. Beside the PowerPoint slide, I also share with you there's one CAD file, DWG file. So inside this DWG file, there will be two files under the file name of floor 1 and floor 2, which is this floor layout here. Because later on we're going to insert our DWG drawings into SeismoBuild Building Modeller Facility and build our structures. Okay, build our models. All right, so I provided some of the detail here is the column details. These are the column size, column reinforcement and trunk reinforcement that we're going to insert into our model later on. And for all the first floor, we got some from the finished floor level to the foundation top level is about 1 meter. All right. So I also give you the detail of the second floor. Actually, first floor and second floor, the column detail are more or less quite similar. They are quite similar. And then the beam details for either both first and second floors, all beam detail are similar. So the size of the beam is 250 by 500 depths, and the reinforcement details and also the triangle reinforcement are similar throughout. I will explain later on what's the meaning of start, medium, and the end middle and the end section later on when we reach the in the beam insertion of the beam detail later on. After the beam, we'll go into the slab detail. Slab detail again is going to be something very similar. The slab detail is going to be the same. Thickness is 150 millimeter, and the reinforcement detail X and Y axis will be 10 millimeter size of bars at spacing 150 center per center. All right, this is a general layout. So let us start with our SeismoBuild modeling now. So I will shift my view to the SeismoBuild software, the program. Let me open up this program here. All right. So this is the interface of SeismoBuild. I believe that you already got one copy. You can try to just double click the icon, and once you go into the program, this is the first interface will reach at the screen. So basically what we got is we will first screen come out, it will call you a manual, will let you decide what kind of structure code and also unit to be chosen. So you can either choose like Eurocode 8 Part 3. All right, in Eurocode 8, we also include some of the national index, which is include beside the Europe, some of the European countries, Singapore, even Malaysia. We already include all the national index into the programs, including United Kingdom as well. Okay, and also ASCE 4041, Italian standards, the Greeks, and the Turkish, as what I mentioned. As for today is the exercise, we focus on ASCE, so basically I select ASCE 4117. So for unit is pretty much quite self-explained. You can either choose SI unit or you can choose imperial unit. So in this case, I try to choose SI unit. The rebar topology is what sort of size of rebar you're going to use. So you can either use European size or US size. So for me, I'm more familiar with European size, so I will stick on the European size. All right. But for you, if you prefer, you can use US size, up to you. All right. So I choose the European size. I click OK. So once I click OK, this is the interface. The interface of SeismoBuild are quite simple. So at the top here is a toolbar setting. This one is some of the basic setting for display setting. And at the far left-hand side is the procedure steps. Okay, so in SeismoBuild, actually quite simple. The workflow are very, very straightforward. Okay, so usually when we work from the top to the bottom. All right, so we will start with building the model. Building model, basically building our model itself, our structures. And then we go to code requirements. This code requirement in relation to the initial stage, what code you have set, what code you have chosen. In this case, we already chosen ASCE 41. So we'll go into this requirement, go into the code-based parameter. We will set like what sort of seismic actions, what sort of performance levels, hazard level, and so on. Later on, I will cover this part. Then after we have done the code requirements, we go into the agent analysis, which is two parts. We look into the first one, the agent value analysis, and then pushover analysis. Then after that, we've done the pushover analysis, then we can have a complete overview, the check of our members in relation to the code-defined seismic methodology. And of course, last but not least, is generate on the reports. Okay. To start with these tutorials, we will start with the building modeler first. Let us go to this building modeling. If we click on this building modeling, it will transfer us, it will come up with the first menu. It will ask us about what is the structure configurations. So in this case here, you can select how many story you want, like 3 story up to about 100 actually. So, but in this exercise here, we only got 2 stories. So we select 2 stories, buildings. And then in each of the story, you can decide what is the story height. So I try to keep consistent. Each of the story height is 3 meters, first and second story. And we can also include underground contribution from basement, up to maximum 3. All right. So, but in this exercise here, there is no basement, so we put it 0. All right. So these are structure configuration settings. We also there's some few basic settings on structure modeling. We can look into the frame element modeling. This is a minimum dimension by default. It says about 0.1 meter. Basically, it's an automation detecting of insertion of the beam. If let's say the beam is more than 0.1, it will insert as a beam. If not, all dimension that less than 0.1 meter, it will not count it as a beam. So these are basically automation elimination of the beam. All right. So beam modeling, we can click into beam modeling. We can include the effective width. We can also try to consider, if we want to consider 0 axial force in shear check, you can click this button as well. There are also some few basic settings on the control mode. In this case, we try to put as a automatic by default values. So everything happy with that, we click OK. So straight away, it will transfer us to the building modeller facilities. So now we go into our building modeller interface, the facilities. You can see that this interface here, we're going to use this whole interface to generate our models. Some of the features, I think is pretty much quite standard self-explained, is like file, save. Then we will start with this middle toolbar here. This is where, like, for instance, how to insert the drawings, moving the structure elements, and to delete the elements. Then below this toolbar here is the insert different type of shape of the structure elements. Like we can insert rectangular column. Every time we click the rectangular columns, there will be some this box explaining to you how to do it. So this section property will come out with explaining. You can put in your section property to insert the columns. All right. Later I will explain this one in more details. And also in the left-hand side here is the snap tools. We can snap any of the object to the drawings or to the objects, to the grid line, and also auto. All right. And this one, this toolbar here is to try to explain about it's zoom facilities. You can zoom in, zoom out, and or zoom to the windows, and zoom to all. So some of the feature we can do is we can insert column. We can insert rectangular column, square column. We can insert L-shaped columns. We can insert T-shaped columns. You can see that T-shaped columns with the rebars. We can even insert circular columns. In this case here, you can see. And we can insert the walls. Okay, and this is a beam, pretty much beam. All right, with all the rebars. And then this part here is a jacket rectangular columns. This one is more for our intervention. We will do it in our second part. For these particular sections, these are our original, let's say for instance, these are our original sections. This one is our new sections. Jacket column, jacket rectangular column, jacket L-shaped columns. Okay, jacket circular columns. You can see the rebar as well, and and also the jacket beam. Okay, beam elements, beam sections. All right. So we also can in this tab, next one tab here, also insert for the slab, and also this tree function is to help you to insert your slabs elements. And last but not least is insert of the staircase. Staircase is something based on our how to say, our experience is some of the old structure. If you include the contribution of the staircase also help indirectly to help you in terms of the seismic performance of the building. All right. So as a start is, let us start with our first model. So to do that is, what we're going to do is we're going to insert our DWG drawings into this interface. So to insert that, you can go to this button here, is import DWG. All right, if you click this button here, you will come up with a box you can go to find our drawing. In this case here, I already saved the drawing in this folder. So because we're going to start our floor, our modeling, our building one floor at a time. So we will start with floor number 1. All right, these are our DWG drawings. Once you select floor number 1, you click open. So the first box it will come up is an import CAD setting. So you have to, based on what unit you draw in your file, like whether it's mm, cm, or meter. So in our drawing here, we are based on meter, so we put meter there. And also we try to move it to the origin point 0, 0. That will be a lot easier for us to work with. So we click done. So it's basically able to insert our DWG drawing directly to this interface here. All right, you can see that. So you can, this one insert here. If you don't want, you can try to hide it. You can show and hide the drawing. If you don't want, you can show, but you can hide. Okay, so in this case here, we will start to construct our building, our first floor. We will start with constructing the column. All right, the column, which is this, is basically 8 column here. We will start with the first column, which is insert rectangular column. Every time we click the column, it will come with this. We're explaining to you how to insert the columns. If you don't want, you can switch it off. Okay, we will start with our first column here. If you go into our lecture notes, in one of the presentation material, the column details for the first floor or second floor, you can see some of the detail there, all the column size, the rebar size. So like the first interface, what you come across here is there's 2 tabs. One is the view and modified geometry. This is what the geometry is. And secondly is the view the rebar. We will start with the first one first. Because for the first column here, if you zoom in, have a look, C1 and C2 is basically the same size. It's 400 by 400. So you can choose these 2 types of standard sections, either rectangular or square. You can choose 400 by 400. Straight away, you can change the dimension to 400 to 400. Or if you want if you prefer, you can type in any dimension you want. Like for instance, I want to put 600. It's possible as well. So you can either type in the exact value of the size of the column you want, or you can choose from the standard section from these two tabs here. So in this case, we choose the standard because it's a standard size 400 by 400. And also in this exercise, this tutorial, there will be some what we call foundations. The foundation, the top of the foundation to the finished floor levels is about 1 meter below the floor levels. So we have to put in the top of the foundation level. In this case, it's 1 meter, so it's negative. It's below the origin point, so it's negative 1,000. Okay, it's in millimeter in this case here. All right. Okay, so it's negative 1,000 per meter. So the section size is 400 by 400. Let me move this one up here. All right, so once you define the section size, the next one is to define the longitudinal reinforcement. So you can see is when I select this part here, it straightly change to the view reinforcement. So in this particular column, the size of the column, we can choose what is the number of the bars and what kind of size of the rebar we're going to provide. In this exercise here, this C1 is basically four number of 18 mm rebars. You can see that every time when we highlight, like for instance, I select corners, this corner bar will be highlighted to yellow color, indicate that you already did this the particular item that we highlight. All right. So in this column here, there is no any top, there's no any side rebar, so we can set it as 0. Okay. So and also if you go to the next one, the transverse reinforcement. The transverse reinforcement in this one is 8. It's basically 8 mm rebar size at a spacing of 200 millimeter or 20 centimeter in this case here. So you can see that similar to longitudinal reinforcement, once you highlight the transverse rebar reinforcement will turn to yellow color. So, and below here, you can even define what's the number of legs. Like in this case, there's a 2 leg in that cross sections. In the height, you can increase to 3 leg, 4 legs. It depends on what's your detail, what's your design. So in this case here is 2 leg. The width also you can do the similarly the same. So width and the height is the same, is 2 legs. And also once you got defined the reinforcement, we can also got a setting for you to define what is the material set. So if you can define the material set, if you click the material set, there's a list of the property here. By default, you already define what is the property value, but you can change it. You can either change by double click here. You go to this table. You can change the name if you want. You can put in a new material set if you want to. We will start with this default existing. You can define about what is the concrete strength you want to put in, what is the concrete strength for the steel, for the concrete and the steel. All right. And you notice that is for the modified existing material scheme, we got one special button here. Actually, this button here is only applied for ASCE, ASCE 41. For Eurocode, we don't have. If you click there, is based on the ASCE 41, they tend to define the history, the time frame of the history of your structure. Depends on what kind of structure elements and what kind of time frame. Is it your building was built during 20s, during 50s, during 60s, or during 70s? It will be a defined value about the strength of concrete and also for the strength of the steel. All right, so this one is quite valuable. It's only applicable for the ASCE 41. All right, cancel. In our case, we're not going to select this one. We are going to select based on our pre-selected values. So this one is based on existing. You can also define what sort of new models, new concrete strength value you're going to put in. All right, so you can see same as concrete and also for the steel strength. So usually it's like if you're doing the seismic evaluation for existing building, usually we use the existing members. So if you do the concrete jacketing, that after you define the existing building, you want to repair with concrete jacket, the concrete jacket, the new concrete is based on the new material. So that's why by default, you already default these 2 values. But if you want is you can add in your own concrete material as well and type in your own name. And then you define whether it's existing or new. All right. So in this case here, we're not going to change anything. So we cancel it, come out. Then the next bar here is FRP wrapping. FRP wrapping, for the first stage here, I'm not going to do anything. But this one is more on defining what kind of FRP system we're going to use. All right. So I will skip this part. Later on, I will explain this after I finish the assessment of the building. All right. So then we can define the FRP wrapping. Then we can also go into the advanced material property. Okay, so this one here, you can define about what's the classification of your member, whether it's primary or secondary. If you look into ASCE 41, they define that. Primary is the primary members that supporting the seismic actions. Secondary member is more for the non-structural elements. So you can define what kind of classifications, the longitudinal types, the lapping, the length of the lapping, and also the accessibility of the area of interventions. And last but not least, is quite important, is a concrete cover. You can define what's a concrete cover in your section. So we can come out from here. And finally, the last one will be the modeling parameters. Modeling parameter is based on, in this case here, we select the default, it's based on what kind of concrete model you're going to use. So these are some of the concrete model you can use in your, for concrete, for steel, and these for what kind of element classes. The frame element modeling. So some of the different type of element you can consider in your modeling. And also some of the other setting like section fibers and also release the moment and so on. You can do it in this part here. But in this case, we're going to keep it as default values. We're not going to change anything. So once we have, we're happy with all the setting, we can go to the view and modify geometry. Then we can start to insert our column. So you can see that is this column here, you notice that there's 9 points. This point here is what we call the insertion point. Is how you're going to insert into your DWG drawings. So in this particular example here, I want to choose my point, my insertion point is this corner. All right. So when you insert is this corner must match exactly to the exactly corner of these drawings. So in this case, before you insert, try to switch on your how to say the snap to DWG function, the tool button here. So you can see is once I move my mouse cursor to here, straight away there will be insertion point. Because I already select the insertion point in this corner here at the left bottom corner. So I insert here and click insert. Straight away they insert the column for you directly. Very simple. Similarly for C2 as well. I click this corner here, it will insert the column for me. All right. So now we move on to the third one, the column C3. So for column C3, the size in this case here is slightly different. Is 250 by 750. You notice that is when you insert column 1, column 2, this numbering also changing for you. All right, this automatically change for you. So column C3, the size is 250 by 750. So we can go to rectangular, choose exactly this column size here. All right, so it's 250 by 750. Okay, foundation depth is still the same. Okay, so we go to the longitudinal reinforcement. In this case here, if you look into your detail, is you need to provide four numbers of 18 mm size rebar at the 4 corners, and also in the how to say in the left, in the top and bottom, we also need to provide 2 extra rebar, which is the size of 14. You have to refer to our presentation material. This is the size of the rebar we provide for column C3. And the rest of the detail, like for instance, longitudinal reinforcement is the same. The rest of the material setting, all the advanced material properties and modeling parameter, we keep it the same. So once we're happy with that, we go to the insertion point. So in this case here, this column, maybe I will try to change the insertion point to this column, this corner here at the right bottom point. So move in here, we can insert directly here. So it's quite simple. So while we're doing that, we can move on to column number 4. So you can see that column number 4, the section size is 300 by 500. Let us go to 300 by 500 standard size. All right, you can change if you want. And in this case here, you notice that the column, the orientation is what I show here is in horizontal, but I will try to, you can try to use this function at the top here. You can change the orientation you want. You can see, change to all 360 degree. In this case, we are trying to put it in horizontal, vertical, 300 by 500. All right, and then the rest of the setting is the same. And the rebar in this case here will be it's a 418 mm rebar at 4 corners, and the two rebar here will be same, two number of 18 mm. Okay, this is the size of the rebar for these sections, and the transverse reinforcement are all the same, and also the rest of the material are the same. So we're happy with that. We do the insertion point. In this case here, we can try to put my insertion point at this corner here. So I go down to this column, then insert. I notice that is for column C4, C5, C6, and C8 are all the same details. So we apply the column. In this particular column, maybe I change to this end here to make it easier. Okay. So once we're doing finish the C6, we can do the C7. You can straightly jump to C8 if you want, but we start with C7 first. C7 is, I think the section size slightly different. Now in this case 250. Let's change using we change to 250 here. We move down to 250, and the size of the rebar is slightly different as well. In this case here is four numbers of 18 mm bars and two numbers of 14. In this case here, slightly smaller. So we change to 14 mm size of the rebar. The rest of the function like transverse reinforcement are all the same, and also the material set and also the rest of the property are similar. So we're not going to change anything. So we move to this column C7, then we insert here. Try exactly match with the insertion point. So this is column C7. All right, this is 250 by 500. And then now we move on to the next one. The next one is column C8. So you notice that is column C8. Actually, it's the same detail, but it's in the inclined position. So what I'm going to do is I'm going to use this. I select one of the previous. I know that is C8 have the same detail as C4, C5, and C6. So I click C4. All right. So straight away in SeismoBuild is the last mouse click section that you click will be the same property already save it here in your section property box. So once you click this one, then you click column. So you can see that all your details C8 is already here. All right, the numbering C8, the section property, all the details are the same. Is exactly for C4 detail, which is exactly the same column that we want to insert. Same column detail that we want to insert. So in this case here, you can see the rebar is exactly the same section. Same longitudinal reinforcement details and the same transverse details. All right. Okay, the way how we're going to do the insertion point is, you notice that is this column is inclined. So we're going to change our orientation to this corner. All right, and then we put our insertion point here in this angle. If we put where is our insertion point, and the angle will be based on their rotation point. So in this case here, I already worked out the angle is about 11 degrees. So I type 11 degrees. So you can see that is already rotated in 11 degrees. All right. So, and then you go into this drawing, you can put the insertion point, this point, if you want to. So I'll try to put the insertion point at this point. And then I insert here. Yeah. So this is how we insert the column with inclined orientations. All right. So in this case here, we already finished all our columns. The next one I want to show you is how to insert a wall. So in insert a wall, you go to the insert a wall dialog box here. Okay. So the wall in this case here is 1.8 meter by 250. So this is a wall. The section by default already give you 250. This is the width of the sections. The rest of the detail like it's the same as a column. There will be a top of the foundation top level will be 1 meter below the floor levels. And also your reinforcement detail for their walls, if you go into my slide, it will give you the detail of the reinforcement. In this case here, we need to define about what is our reinforcement detail. Let me scroll down here. You can see there is two corners. The corner means is a corner of the studio columns here. These two columns. So column 1 is the left hand side. Column 2 is the right hand side. So similar to column, it will highlight the, once you select the bar, you will highlight the details. So let us start with from this column number 1. If you look into our detail, is 4 16 mm bars. So we change to 16. Okay. And then in this particular example here, the width axis, there is no, I don't think there's any rebar in this size. And then in this strong axis here, there is two number of 14 rebar here. Okay. Same as the other corner as well, is 4 16. And there is no rebar at the width axis, so we can put it 0. And the size along the strong axis is 2, and is 14 as well. So select 14 here. All right, so we already defined the two pseudo columns details. Now the middle one, if you notice the middle rebar, which is highlighted the middle here, we're going to provide 8 numbers of 16, 8 number of 8 mm bars. So we go to select 8 mm bars, 8 number of bars. So we select 8 here. So it will be well distributed top and bottom. All right, so we're done with our longitudinal reinforcement. Now we move on to the next one, is a transverse reinforcement. So transverse reinforcement in this example here, we also provide the same as our column. So it's 8 mm at 200 mm center to center. So 8 mm, so change to 8. So it's 200, it's 20 centimeter. Similarly, for the other edge as well, you can see that every time when you select which side, which edge, the particular link detail will highlight. And this one is a 20 cm. Okay, 20 cm. The internal grid is the same as well, 8 mm and 20 centimeter. So similar to column, you can put in how many legs you want. Like this one is how many legs you want to put in, how many legs you want to put in at the height and at the width. So in this case here, we don't need. So we'll put it 0, put it 2 legs. Same as the middle part here as well. You can put in how many legs for the middle sections. So in this case, we try to keep it by default is 2. All right. So we done the reinforcement. The rest of the setting is the same as column. We keep it as by default. We're not going to change anything. So now we're going to show you how to insert the wall. So for the wall is, if you look into this wall here, you notice that there's a 3 parallel line. This parallel line indicate that is the line of how you insert the walls. So in this particular wall here, you can either insert at the middle line here, but in this particular example, it will be easier. We start from the corner. All right. So if you select either this which line you want, and for instance, I select the top line. So I will move here. From here, I will click my wall. All right. Then, because you notice that I already select this snap to auto is on, so I switch off. Then it will be, following the line here. So we can select the next line. You click. This is how you insert the wall. It's very simple. All right. So if you select this select element button here, you go to select this wall. These are all the property in the wall. You can double check back again if you want to. And in this wall here, you notice that the dimension is slightly on the way here. We change back to 1008. All right. So there's a 2 settings you can do. You notice that is the length you can change, and also here, this is what we call the pseudo column width. What I mean is this width here, the width of this particular column. So if I'm not mistaken, if you look into the standard, usually the way how we calculate the column width is 1/5 of the length of this wall. So just now we already changed to 1006 1/5 is 1008 divided by 5 is about 360. All right, so you can see that this is a 360 width of this pseudo column width. We can set that. All right, so now we're done with our walls. We're going to move on to our next section, which is we're going to insert our beam. So the beam here, you will select this setting here, insert beam. Same, the message will appear to explain to you how to insert a beam. So in this beam here, our beam detail here as what we have, let me go back to my presentation slide. The beam detail here is the beam width is 250 by 500, okay, height of the beam. And these are beam reinforcement details. All right. So if we go to the SeismoBuild, okay, I go to the initial part here. So we can choose based on what setting you want, like 250 by 3, maybe I can use type 500. So its width is 250, the height is 500 here. And then in terms of the reinforcement here, okay. The internal reinforcement here in SeismoBuild basically is divided into 3 sections for every beam. Let me go back to my slide. You can see that is in this drawing here, what I show here is these two blocks here representing columns. In between the 2 columns will be the beam spanning. So we had to specify 3 sections of our reinforcement details. So usually SeismoBuild, you need to define when we talk about start will be at your left hand corners, end will be at your right hand corners, or based on what is the direction of your insertion of your beam, and middle will be the middle. So you have to define the three sections of your longitudinal reinforcement. All right. So in this example here, I give you the details like. The start, the end is the same detail. The lower bar is 2 number of 14. The upper bar is 3 number. And the middle is bottom one. The lower is 4 number of 14. And the top is 2 number. So we're going to insert this value into our SeismoBuild. Okay. So just now I already mentioned the reinforcement details at the lower for the start is 2, okay, 14. Upper here is 3, okay, and it's 14. And the side here, in this case, there's no rebar, so we put it 0, all right. And for the middle one, the lower one is 4, okay, and the size of the bar in this case here is 14, all right. And the upper one is 2, 14. The side one is 0. There's no sidebar. We put it 0. And the end is basically the top here is 214, same as the start. And the bottom one here is 3. Actually, we change back to 3. Okay, 14. And the side one is basically 0. There is no any sidebar, side longitudinal bar. So we're done with the longitudinal bar. The next one is we can set in for our traverse. In this case here, the traverse are all the same. It's 8 mm of 20 centimeter, 200 millimeter center per center. Similar for the middle one as well. So 8 millimeter by 20 centimeter. And the end sections is 8 millimeter by 20 centimeter. So similar to column, we also can define the number of legs in our basically in our sections. Okay, so so once we have done our transverse rebars, in our beam section we also can add in additional permanent loads, which is the G dash in this case here. All right, so if let's say in your beam you got extra brick wall on top, you can work out the brick loading and add it here. And also you can, similar to the column, you have to set in the material setting and also advanced member properties and also the modeling parameters. Okay, so once you're happy with all these things here, then we can go to our view and modify geometry. So to insert the beam, actually in SeismoBuild, the beam is quite simple. So let me, Similar to the wall, you have to select what's the insertion point. All right. So in this case here, I will select maybe the bottom as our insertion point. All right. So in this case here, I will select from this column, in this column here, and to this column here. So you can see that is SeismoBuild. Basically, in every one beam is spanning in between the two columns. So if let's say just now you see, for instance here, when I try to draw the beam spanning from C1 to C3, in the middle is a C4, it will automatically break it into two beams. So basically, when you insert the beam, you don't need to insert column to column. It saves you a lot of time. Let's try to demonstrate again. Maybe let me try to insert this beam here, the whole stretch of the beam from this bottom. Let's say insertion point from this bottom, moving outward to this corner here. So we can see that you automatically break it into three beams. So beam 3, beam 4, and beam 5. So we can do the same thing at this corner here. Now we changed our insertion point to this end, to this corner to this end. So yeah, you can see it can create a beam for you straight away. Now we do the insertion for this beam, the same insertion point from this point to the top. Okay, so insert the two beam for you straight away. And then now we insert this beam here. Maybe we select the bottom insertion point, easier, and do here. So automatically select for you. And last, we can insert maybe from this corner, this beam here, to this beam, to this column. Let me see. Yeah. So insert this beam. So you notice that when I insert this beam, this initially considered as one beam, you automatically break it into two beams. All right. So it's quite convenient for you. And last, we want to insert the incline. We select the top inclination. Okay. So this corner to the top corner here. Okay, so we done. We already done the whole beam for this floor. I noticed that there is some two extra beam create more small pits here. We can delete it because we don't need that. Okay, it don't represent it, don't carry anything, so we didn't delete it. So that's it. We complete the beam for the first floor already. So once we done our beam, the next step what we're going to do is to try to insert our concrete slabs. So for the concrete slab is quite easy, but simple. We go to our insert slab function. So in the insert slab functions, it is the module, the section property modules. So first thing is we want you to insert what is the height. The height of our slab is 150. For initially when you insert, basically these two table or two columns, it will be blank. But later on, I will show you what's the function of it. Doesn't matter. We move on to the next one. For the size of the bar, it's 10 mm with a spacing of 15 centimeter. Let's go back to our slide to check. Is it the same? Yes. It's basically 150 mm thick, and the size of the bar is 10 at 150 mm center per center. Okay. So this is exactly the rebars arrangement. And also in terms of loading wise, we can put in the loading applied on the slab, okay, for each panel. Okay, if you want to. So first thing is you can calculate the permanent load. In this case, the G is our cell width. So you can see that it can automatically calculate based on the thickness of the slab that what we defined earlier. Just now we defined 150 mm, so we already automatically calculate. If you don't want, you can unclick this one, you can type in the value you want, up to you. All right. And also include the G dash. G dash is the additional permanent loads you can put in. The Q is a live load, the variable loads. You can select from the type of the loading areas based on what is the occupational purpose function of that building. You can select from this value or by default from the code. And S is basically the snow loads, so you can define the value from here. And also there's a function for slab is you can also define slab inclination. All right, this one is I won't be showing here, but there's an additional function for slab inclination. So once you're happy with the loading, everything, all right, so we can insert the slab. To insert a slab is quite simple. Insert a slab usually if let's say you already got the boundary condition already defined, already confined by the 4 beam. insert a slab, it can direct apply the slab directly onto it. Like for instance here, slab number 1, because this boundary condition is by 4 beam and the column, if you click this area here, it will automatically insert a slab for you. So same as slab 2, slab 3, and slab 4. Okay, so once you insert the slab, let us go back, we select element again. Okay, let us select this slab. So you notice that initially when you insert the slab, there will be these 2 columns empty. Now there is something shown in these 2 tables. What is showing here is showing you the edges and the support condition of this particular slab. So the solid green line here representing is supported. If let's say you decided that you want to change this support condition to, let's say, in this particular beam here is beam 15, you want to select, if you click this line, it will become a dashed line. This beam 15 here will be representing free. Free means it's a pin joint. All right. If they say you don't want the loading to transfer to beam 15. All right. So the green line representing supported. That means representing fixed support to the beam. All right. Rigidity. All right. In this case, we maintain it. So once we done the slab, we can see that is the first floor already completed. So once we completed, we can check our 3D views. So what you can do is you can go to this function here, view story 3D models. Okay, let us double check. We click this model here, click the view story 3D model to see our 3D model of our buildings. So you can see that this is a 3D view. Everything looks fine, looks perfect. So that means we complete our first floor already. Now to do our second floor. For second floor, the details are the same. So what we're going to do is, if you select this button, you see this button at the top here, floor. Now we're in the first floor. If you select the second floor here, you notice that it's blank. Okay, basically we haven't completed our second floor. So we want to construct our second floor because the second floor details are the same as the first floor. So what we can do is we can select this function, copy floor. Okay, I click this function here. So you can copy the detail from first floor to the second floor. Quite simple. All right. So if you click OK, it automatically copy for you. Now you select second floor. Let us see how. So you can see that it shows the detail here. Now if you go to the 3D view, the view story or 3D models. Okay, you should be able to view the 2-story here. All right. So it's saving you quite some time. To create these models. Okay, once we're doing that, okay, so now we can move on to our second floor here. Okay, the second floor setting. Okay, so we are going to make some changes in the second floor in order to reflect to the details. All right, so what we're going to do is we're going to insert again the second floor details, the drawings, the DWG drawing. We import again to this DWG floor number 2. Okay, we insert the drawings. Again, is the first setting will ask you what you need and also move to origin. I say OK. Okay, so now we already insert our drawing here at the behind of this model. We later on we will make the adjustment, but we need to make some trimming. Some of the members we need to delete some of the members. So to delete that is okay. Use this function delete elements. All right. So to delete the element in SeismoBuild is quite simple. There's a 2-way. We can either use rectangular selection. What I mean by rectangular selection is if you create rectangular, any members or elements that inside this rectangular selection will be highlighted in pink color, will be considered as selection. So you can click this button, then click delete. It will delete for you instantly. Or alternatively, you can select the element directly using this button. It can delete for you instantly, directly. No need to do anything. It's quite easy. Okay. So once we've done this selection of this delete of these few members, elements, we can go back to this select element again. You notice that is the drawings and the model are not matching, not in line. So what we're going to do is we can try to align this drawing by using this function here, move exit center. Let me show you. If I click this button, you notice is when you click this button, a red point will appear here. All right, red point representing the point of the exit. All right, so we can see that you can move the model to this drawing. Okay, this one way. This one way you can do that. There's another way is, personally, I will prefer this method, which is move the DWG. Okay, so in this function here, you can select the base point. Select the base point is usually the base point of the drawings to the second point here. Then you should move. So automatically it will move precisely to the point that what you're looking for. I felt that this way I will be more prefer this way, but it's up to you. Okay, so once we have moved our model to our second floor drawing, the last element that we need to construct is a concrete floor here. It's a cantilever floor. All right. So just now, as I mentioned to you, is the slab we need to have a boundary condition of four beam. But in this type of slab, cantilever slabs, we don't have any beams. So what we're going to do is we need to improve. We need to insert what we call the slab edges, which is the boundary condition to insert the slab. So to do that, it's quite simple. We need to insert our edges. So we go to the parameters, like we start with this corner here to this corner. We select the edges of this slab, this corner, to finally this corner. Okay, so we click apply. So you notice that is when you insert the edges, the blue line will appear. All right, this is basically the edges that for this cantilever slab. So then we go back to this function. Before we doing that, because we can try to using select elements, click one of the elements, because I think the slab is exactly the same property. Then select insert slab. So all the detail from the previous selection are already factored inside, already saved inside here. Then we select this point. So it automatically insert the cantilever slab for you. All right. So again, is these two tables straight away will appear here. All right. It will appear here indicating the edges and also the support conditions. Okay. So once we finish this this slab, we can go back to this view story 3D model again. Then it will let you have a look at, check through your 3D model, see whether everything looks okay. Yes, I think everything looks fine now. So now we finish our model, okay? So we can move back to our SeismoBuild platform to do our assessment. So we can click this button, exit, and create a 3D model. So before you can do that is we have to save our files. So let us save to tutorial number 1. Tutorial 1. So when you save, it will transfer back to the SeismoBuild main platforms. All right. So we'll come back here. Oh, maybe let me try to clean up something. Clear up some drawings. All right. Okay. Once we come back to this this interface here, that means we already create these models.